Hi students, this is Dr. Kavita from SNS College of Technology. In this session we are going to see about the very important topic, the centroid of area, volume and mass. So this is coming under the properties of surfaces and solids. So as a civil engineer it is very important. So before analyzing and designing any component, we should know about the basics of the basic properties of the solids. So here in this session I am going to discuss about the what is the basic definitions of centroid and centroid of mass, and how we can determine for different shapes. And if you are taking the regular shapes, for an example rectangle, square and circle, so it is very easy to find out. But if it is a composite shapes, and also the if it is an irregular shape, it is very difficult to find the centroid. So now we will discuss about the centroid of different shapes, and also how it is used for the civil engineers. So what are the applications of this centroid? So first getting into this, first you should know that what is the meaning of centroid. If I am taking this, there is some 2D figure. So here it is the geometric center. The centroid is nothing but the geometric center of the given figure. So if I am taking this triangle, so if I am joining these all the apexes, so I will get this is the common point. This is the geometrical center for this rectangle. So similarly, if I am taking a square, this is the geometrical center, and likely for the circle also. So here it is a point where the entire area or length or volume can be considered to be constant. So if it is a 2D figure, we will consider the area. If it is a 1D, we will consider the length, and if it is a 3D figure, we will consider the volume. So we will see that. First, we will see that centroid of the plane areas. Centroid of plane areas, which is nothing but and the composite areas, and what is the method, and what is the use of the symmetry. Now you can see this. So this is a centroid of the simple shapes. Here this is a rectangle. For rectangle, the x bar will be at center. And also at if I am taking the triangle, if I am taking the base as this x-axis, the base, from the distance of h by 3, if I am taking the height of the triangle is h, the h by 3 at h by 3 from x-axis. And if I am taking the semicircle, if I am taking that x bar, it will be a d by 2, and it is a y bar, it is a 4r by 3 pi. So similarly for different shapes, the centroid, it is a simple figures. So directly by using the formulas, we can calculate the centroid. And here these are the formulas which I have given here. Before knowing the centroid, we should know that areas. So what is the formula for area? So these are all the very basic things. Area of the rectangle is b into h or b into d. The x bar is b by 2, and y bar is also, if I am taking the height depth as d, it is a d by 2, or it is a h, it is a h by 2. So similarly, if I am taking the semicircle, the area is pi r square by 2, and if I am taking this, the reference axis here, the x bar will be d by 2. If I am taking the reference axis as at center, the x bar will be 0. So, but here the y bar will be 4r by 3 pi. So similarly, if I am taking this triangle, this is the area of the triangle is half bh, and the y bar will be h by 3. So from base it is a h by 3, from apex it will be 2h by 3. And here you can see this, it is a semicircle, the same semicircle, but the base is at the y-axis. So therefore here this x bar will be 4r by 3 pi, and the y bar here it is at exactly at thing. So therefore the y bar is 0. So next if I'm taking the circle, the area is calculated by pi r square, and here the x bar, the x-axis and y-axis is exactly at centroid. So therefore the x bar and y bar is 0. So if it is here, the x bar that is the central axis, the x-axis and y-axis is here. If I am taking the x-axis, y-axis, the reference axis, the x bar and y bar will be t by 2. So similarly for quadrant, the x bar, y bar is nothing but 4r by 3 pi, and area is pi r squared by 4. That is a 1/4 of circle. So there are different methods are there. First one is a geometric method. Then next one is a method of symmetry. Then method of moments, or otherwise we are calling that as a first moment of area. And the next one is a composite shapes method, and integration method, and a graphical method. So the next one is the centroid of volumes. So if it is the 2D picture, by using the centroid area, we can find the moment of inertia. If it is 3D, we have to find the centroid of the volumes. So here these are all the approaches are given. And next we will see about the center of gravity. So what is the center of gravity? Why it is very important? So the center of gravity is nothing but it is an imaginary line of an object where that it is assumed that whole weight of the body is assumed to be acting. So therefore, if it is in the balance point of an object, and if it is supported at its CG, okay, then the body will be in equilibrium. Okay, so for an example, if I am taking this, so this is a rectangle shape and it is a regular shape. So here if I am taking this, the CG will be at center. Okay, but here it is some it is a trapezoidal shape, and it is the CG will be calculating by using the formulas only. We can calculate, but for calculating the CG of this rectangle, there are some direct formulas are available. Okay, so here when the body is in equilibrium, so when the object is balancing that the CG at center, then the body will be in equilibrium. So for an example, while we are traveling in the boat, okay, so the persons are sitting, and at the both the corners, the weight of the persons who are sitting is balanced at both the edges, then the boat will be in equilibrium and there won't be any issues in the moving of boats. So for an example, if in one corner some 10 persons are sitting, the total weight of that person is some 500 kg, and the another side only the 2 persons are there. If it may be some 100 or 200 kgs, then the weight will not be balanced in both the things. So then the body will not be in equilibrium. In that place, you can see that if it is in stable equilibrium, so half the body is there. Okay, and if it is an unstable equilibrium, half the thing. So here the CG in these things, the CG will not be in a at center. So here I have given some examples. The two kids are sitting in the seesaw and they playing the games, and here this is a CG of this seesaw, and the weight of the persons are same, so therefore the CG will be at center. So you can see this the seesaw in equilibrium. Okay, and the next thing here the center of gravity is here. Okay, so the person who is standing, and it is that person is supported by means of some floors, then CG will be at center. Okay, and but that same person they are running or walking. Okay, and here the center of gravity will be, it will not be at center, it will be somewhere other point, and also it will be keep on changing. It is depending upon the posture of the person who are walking or running. Okay, and similarly you can see this the person who is walking like this, and some person is some handicapped, the person is walking like this, and that person is using the walker, and then the CG will not be at center. Okay, so you can see this this CG will not be the same the thing. So it will be depending upon the position also. Okay. So therefore, the studying of the CG is very, very important. Okay. So now we will see that what is the difference between the centroid and center of gravity. Okay. The centroid is nothing but the here this is the intersection point of the all the points, that is a geometrical center. But here if I am taking the CG, it is the point where the whole weight of the body is assumed to be acting. Okay, so if the CG is at center, then the body will be balanced as we discussed in CISA, or otherwise the CG will be, if the CG is not center, then the seesaw will not be in the neutral position or balanced position. So therefore, if and also if you are designing any structures, the thing to understand the how we have to calculate the centroid and center of gravity. So I think by using this session, you could understand some basics of the centroid. Thank you.